The broadcast is now starting. These are in listen-only mode.
Hello, everybody, and welcome to the Gala webinar series. My name is Manuela Noske, and I'm the Communications Manager at Gala. Gala is a global, nonprofit trade association that enables communication and business across languages and cultures. We're headquartered in Seattle, Washington, in the United States. And today we have a presentation by Spence Green from Lilt, who will talk to us about how you can scale localization with artificial intelligence and automation. But before we get to this topic, I need to go over our housekeeping items. Everyone's lines are muted to cut down on any noise. If you have any technical difficulties, let me know by using your chat box, and I will work with you to troubleshoot them. If you have a slow internet connection, your audio may be disrupted. If that happens, you can use the number listed on the GoToWebinar panel to call in using your phone. We are making a recording of this presentation, and you will be able to find it following the presentation on Gala's global website. All participants will receive a link to the recording by email. If you have any questions or any comments, please type them into your chat box, and we will try to get as many of your questions as we can with the time remaining after the presentation. Next, let me introduce our speaker. Spence Green is the co-founder and CEO of Lilt, a San Francisco-based enterprise language translation company backed by leading venture capital firms like Sequoia Capital and Redpoint Ventures. Prior to founding Lilt, Spence graduated from Stanford with a PhD in computer science under the direction of Chris Manning and Jeff Hare. He has published papers on machine translation, language parsing, and mixed initiative systems, and given talks on translator productivity. In addition to his PhD, he received a MS in computer science from Stanford and a BS in computer engineering from the University of Virginia. That's it for the preamble. It's time for the actual presentation. Spence, the floor is yours.
Okay, thank you, Manuela. I hope everybody can hear me all right and can see the screen. So let's get started. We got a good amount of material to go through today. But let me just start by saying thank you for being here this morning. I know that this is a complicated and stressful time in the history of the world, and a unique and uncommon time. And so you're taking time out of your day to talk about something that may seem less significant than the very difficult issues that people are dealing with in the world. So I hope that this morning this can be a little bit of a break from the difficulties that we're all experiencing right now, and then we can have a little bit of fun and learn something in the process. So again, thank you. I hope you're safe and healthy wherever you are, and I thank you for joining this morning. Okay, so here's what we're going to talk about. We're going to talk about the usage of automation and artificial intelligence in our industry, which is translating words. And these two topics have significant implications for business processes generally, and for the future of work. And that's obvious. That's not a very interesting observation. The thing that is interesting is that while artificial intelligence over the last couple of years has sort of been in the mainstream news, actually these trends have been at work for a very, very long time. And there are other industries where automation and artificial intelligence have had enormous impact in transforming the way that work is done. So an obvious one is in call center automation. Call centers are actually pretty complicated. When you call up an airline and you want to change your ticket or ask a question, your call gets routed through different locations. You may get routed to different people who speak different languages, and then you get routed to somebody who has the skill to answer your question. And actually, when you do this, oftentimes you speak to an agent, like a system a speech system that will take a question and generate an answer, and then do routing based on what you say. And so that's a machine doing that. Now there's still people in call centers. It's just we use AI and automation to have fewer of them, so we can handle more calls with fewer people. and we use automation and AI to do that. And in fact, there are companies now that you can buy an entire call center automation product. Amazon sells one, for example, where you can apply AI tools to set up a call center. Self-driving cars are one that are in the news a lot, but actually we've had these sort of 5 levels of autonomy, and what gets in the news a lot is people working on level 5 autonomy, which is when you don't have a driver. But actually, automation and artificial intelligence have been applied to cars for a long time. In fact, most of us are driving a car that has level 1 autonomy, which is known as hands-on autonomy. And so these are things like cruise control, parking cameras, and lane following. Those are all examples of automation that automate various parts of driving. Probably the most prominent example of autonomy is Tesla's products, so-called autopilot is the way it's branded, but actually this is only level 2 autonomy. So it can do things, you can take you're not supposed to, but you can take your hand off the wheel if you want, and it'll do lane following and acceleration and deceleration. What's in the news is steering wheel optional, which is level 5 autonomy. And these are the so-called Robo Taxis that we were promised a few years ago. So there was a bunch of proclamations, breathless proclamations about 2 years ago that we'd have Robo Taxis by 2019. And now it seems like that's not anywhere in sight. And actually, this is a theme in the history of artificial intelligence of overpromising and under-delivering. It goes back to the 60s. And so that's nothing new in the world. But it is the case that the systems, even a system like autopilot level 2 autonomy wasn't possible a few years ago. So there is real progress being made. And the one that's more relevant to what I want to talk about is factory automation. So on the left-hand side is the production line for the Model T at Ford 100 years ago. And actually, you can see automation here. There are conveyor belts and pulleys and things hanging from the ceiling that get lifted into these cars. And on the right, you have Tesla's production line, which has a significant degree of robot automation to manufacture cars. It's not the case that there are no people in Tesla's factory. There happen to be a lot of them. It's just that machines are used for a lot more of the work than 100 years ago at Ford. And actually, I think this factory automation idea is probably the one that's most applicable to localization. So we're going to talk about that today. We're going to talk about localization as production. And the example that we're going to use is actually making breakfast. It's breakfast time here on the West Coast. And breakfast is a pretty illustrative example for thinking about production. We'll talk about production objectives, the key inputs and outputs of production and localization. And then we'll go into the production process itself, and we'll look at the places where we can use AI and automation to optimize that production process. And then I'll leave you with some homework and some questions to ask for the processes that you're managing. Okay, so that's our plan for today. We'll get through this hopefully in about another half hour, and that'll leave 10 to 15 minutes for questions. Okay, so let's get started with breakfast, and we're going to talk about a simple breakfast of eggs, bread, and coffee. And this isn't my example. This actually comes from Andy Grove, who is sort of a CEO that I admire a lot. I never got to meet him. He died a few years ago, but he's admired widely by a lot of people who do the job that I do. And the reason for that is that Andy was a technical person. He had a PhD in chemical engineering, and he went on later to use those scientific gifts to think about production and about the management of organizations. And he wrote this awesome book in 1983, which if you're in management, I'd highly encourage you to read, called High Output Management. And when you pick this book up, you would think, okay, he's going to go into semiconductor manufacturing, which is what Intel did and what Intel still does. But in fact, he uses a simplifying illustrative example, which is what good scientists do. So he takes a simple example of something that's easy to reason about, and he uses that to demonstrate the basics of production. And that example is what he calls the breakfast factory, which is a cafe that makes this breakfast. And so our task in the breakfast factory is to serve a breakfast of a soft-boiled egg, toast, and coffee. And our objective with this in the breakfast factory is to deliver these 3 items simultaneously each of them fresh and hot. So when a customer makes an order, we want to make this breakfast as quick as we can, and we want to deliver it fresh and hot. So our goal and our charter in production is to build and deliver products in response to the customer at a scheduled time, at an acceptable quality level, and at the lowest possible cost. And crucially, production's charter is not to deliver whatever the customer wants, whenever the customer wants it. So here we are in the breakfast factory, and the customer walks in and says, I want a T-bone steak and I want it in 3 minutes. That's not production's charter to respond to that. Instead, production has a very specific product that it's delivering, and it tries to optimize that process. And here's the little diagram that appears in the book on page 5. So you have a customer order, and you map out all the components of delivering that customer order, and you find out that the eggs are actually the limiting factor. In other words, they take the longest amount of time to produce. And so you spend your time optimizing the egg. Okay, so the breakfast company has a great product, and it's a product that is pretty universal. People around the world like eggs, toast, and coffee. So the breakfast company decides it's going to scale. We're doing pretty well in the United States. People like the product that we're selling. We got a killer product, and we think that it's going to sell well internationally. So the breakfast company decides that it's going to create a localization department, because when we start setting up breakfast cafes all over the world, we're going to need to localize the marketing, localize the website, localize the menu, and localize all the training material for training the people. We want to have a consistent brand experience worldwide, so you can go anywhere in the world, go into the breakfast company, and get this great breakfast. So here's the team that we've set up. So we've got a head of localization, we've got one project manager, and this is a pretty progressive localization team. So we also have an engineer who knows something about machine translation. We've got a software stack that we've built. We went out and we selected a TMS. Again, we're pretty progressive, so we're doing terminology management too, and we're using custom machine translation. And then finally, the final component of our stack is translation services. Now, the breakfast company is in the business of making this egg toast and coffee breakfast. It's not in the translation business, so we've chosen to outsource translation services to a vendor. Now, I'm going to make a couple of simplifying assumptions that are going to make the example a little bit easier to understand. And of course, your particular situation may differ, but I think you can use this example and this template and modify it according to your particular situation. So the assumptions we're going to make are, we have 100% human translation. We don't have any applications for raw MT. We're not going to consider TM leverage in any of the production calculations we're going to make. I just think of TM leverage, if you have a recycling rate with exact matches, you can just increase your production capacity with the same cost. So we're not going to factor that in to make the math easier. We're not going to include any hourly post-production. So these are linguistic services like DTP. And we're just going to assume that everything has the same turnaround time that's greater than 24 hours. So we're not going to do any less than 1 hour turnaround or anything like that. We just have a standard turnaround time SLA. Okay, so that's what we're going to do. The breakfast company has made the decision to sell worldwide. We've got this localization department, and this is how we're going to proceed. Now, if we take Grove's notation and we write a little production flow for localization, this is what it looks like. We have internal customers, say like the marketing team, who says, I want to translate this marketing campaign. That'll go into our TMS where we create a job. It goes to the outsourced translation services provider, where I'm calling translation here, including both translation and transcreation, and it goes through a TEP process. Then it comes back into our TMS, and we do a little bit of QA, and then we deliver it back to our customer. So we can see here that translation is the limiting step in our production process. Okay, so the first thing that we need to do in our production process is figure out what our objective is. Remember, the objective of the breakfast company is to deliver this breakfast, those 3 components of the breakfast simultaneously, fresh and hot. What's our objective in our localization production process? Well, the first one that comes to mind is quality. And this is what people tend to say is their objective is quality, but actually this isn't a very good objective in isolation. If quality is the only thing that you're optimizing for, then really you're in the zone of literary translation, and I'll talk about that in a minute. There are obviously other factors that you have to consider in a business. One of those might be budget. So most of us in localization, or if you're like me and you're running a company, we have a fixed budget, and we've got to do as much as we can with that budget. Now, if budget is the only thing you're optimizing for in isolation, this tends to be more like user-generated content, and you're just going to use a machine translation system and translate as much as you can with that fixed budget. You might also think that time is what's the main thing you want to optimize on. You want to do this really, really quickly. And if that's really the only thing you're optimizing on, usually you're in the zone of something like customer support, where you're trying to translate something as quickly as possible. It's like a ticket or a call or a support chat. So any one of these in isolation is not quite the right thing that we want. It doesn't fit for what we're trying to do at the breakfast company. And quality is the most interesting one because it's what everybody says is their goal. They want to get their brand, voice, and tone correct. And my suggestion is that if this is kind of the goal, then I was looking into this translation of Flaubert the other day, and there's an article about Adam Thorpe, who's the translator who translated Flaubert, and he spent 3 years translating Flaubert's masterpiece from French into English, trying to get the voice and the tone correct. So this is kind of an extreme case, but you can see here if voice and tone are the only thing that you care about, then you should hire Adam Thorpe and let him go at it for 3 years, and you'll probably get a great result. Your company might sort of be out of business by the time he finishes, but you'll get exactly what you're looking for. So that's kind of an extreme case. And obviously we have other constraints that are not just getting voice and tone right. So what I want to propose is that our production objective in the breakfast company is what I'm going to call reach, which is we want to translate the maximum number of words at high quality under a fixed budget. And actually, this is the scenario that we're in for enterprise localization. We're trying to do as much as we can while maintaining our quality standard, and we're working under a fixed budget. Okay, so this is going to be our production objective, which is to maximize reach. And now, crucially, quality is an important component, but it's a component of reach. It's not the production objective. So there are two things that you need to think about in setting up a quality program. And actually, I think that the best example, the best definition of quality comes from the preface of the MQM standard. And it defines quality as text that adheres to appropriate specifications. And I want to suggest that that is what we're after. We're trying to translate things according to a set of specifications. We have one of our customers that uses shorthand for this, where this customer calls translation quality, we want to achieve usable translation for the right price. So here again, we're trying to create translation that's usable, and we have a budget. So how do you establish quality? Well, you need two parts, and we will set this up in the breakfast company. We need a specification. What are we translating to? What are the guidelines? You can think about this as like blueprints for a house. And there's a great place to start. If you've never written a translation specification, there's a standard ASTM F2575. You can look it up. And that's a great template for creating a translation specification. And then once you have a specification, you can assess the products that are coming out of production according to that specification. And again, MQM offers a helpful definition of what an assessment framework should be, which is measuring how a product complies with quality specifications. So too often there's a lot of focus on the assessment framework and on LQA, and too little focus on the actual specification. What are we doing in our production process? What are we building? What are we building our product to? So we need both. We need a specification and we need an assessment framework. Okay, so when you think about production, you want to think about key inputs and outputs. And here are the outputs the inputs and outputs for our process. So our inputs that are fixed are the following. We're told by management that we have 800K to spend. We can negotiate that a little bit, but for the most part, we're told our localization budget is 800K. We're also told by management that the breakfast company is going to open up in 5 countries, and so we have 5 target languages. We're going to translate 2 products, and each of these products has about 200,000 source words. And because we're a progressive localization org, we've gone off and defined a quality specification for each one of these products. And our key outputs of production are translated words, of course, for every language and product. And then we also get a quality assessment score per our QA frame. Now I use the word product here. People often this can be a content type or a workflow or other words that people use, but I'm using it to represent the things that we're localizing. So these could be software UIs, they could be e-commerce listings, they could be support articles, PowerPoint decks, and so on. The units that we're translating in our production process. And if we think about them as products, usually this is how we can arrive at these estimates of how many source words are coming in through each product, and then how many different products are we localizing. And typically, if we can convince ourselves that there's a difference between two different products, then we probably ought to have a different quality specification for each product. So obviously, if you're translating software UI strings and you're translating marketing PowerPoint decks, those likely are written to different standards, and thus you want to have different quality specifications for translating. So this is the way I think you can think about internally your workflow. How many products am I translating, and do I need a quality specification per product? Okay, so we need a key production metric, and I want to suggest that in our production process, the source word, which is what we're producing, is the key metric. So the key metric is then the total cost per word. And here's what our budget looks like. So we have a team, we have 3 people, and here's some salaries that we're going to pay them. This may be slightly more or slightly less than what you're paying in your org, but this should be in roughly the right ballpark. We're going to spend about 100K on software. And then when we subtract out the people and the software, we've got about, we've got a little bit of money left over for translation services, which our LSP is charging us 20 cents per word. And we have 2 million words to do, so that's $400,000. So if you do your arithmetic quickly, you'll find out we have a problem here, which is that if I take the 800K budget and I subtract out the people and software, I only have 240K to work with for services. 240K is gonna, at 20 cents a word, is only gonna let me produce 1.2 million words. But if you'll remember, we had a goal of producing 2 million words, and that's actually gonna cost us $400,000. So we have a shortfall of $160,000 or 800K words, and our total cost per word is 66 cents per word. So oftentimes people focus on what they're paying their LSP. Oh my gosh, 20 cents per word. We're doing okay here. But actually their total cost of production is 66 cents per word when you add in the software and the people. And so our reach then, the percentage of the total words that we're translating is only 60%. Our production process can only cover 60% of the 2 million words that the management and the breakfast company has asked us to translate. And actually, I suspect that a lot of you are in this situation, which is that you can't produce everything that you need to produce for your company, given your budget. And so you have to make compromises, which means maybe we decide, okay, we're gonna, in Germany, the website's not gonna be as good. We're not gonna translate as many pages. We're not gonna translate all the training materials for the employees. They're just gonna have to make things up. And these are the sorts of compromises that we have to make in localization, because we don't have enough budget to translate all the words that are possible. Our reach is less than 100%. So now this is the problem setup. What we're gonna do is we're gonna try to use tools to optimize the production process to increase our reach, okay? And that's our whole goal. And we're gonna use a variety of tools all throughout this production process here, which we've set up, pretty standard production process. We're gonna apply automation and AI in different parts of it. And we're gonna do that with the intent of increasing our reach so that we can translate all the words that we've been asked to translate by management, given the budget that we have. So recall that translation's our limiting step. It takes the longest amount of time and it costs the most. And the really good news here is that the current state of AI language tools gives us the most leverage here. So it's reasonably difficult to automate what the head of localization does, which is consulting with internal stakeholders, managing a budget. So I'm not really known how to come up with a software system that would do something like that. So we don't have much opportunity for automation there. But we do have significant opportunities for automation for things like file transfer and various parts of the translation production process, because these are sort of where we are with the tools. And so you can think about this as, in going back to the self-driving car example, and different levels of autonomy, where we are with language tools that are down around level 1, level 2. We're not anywhere close to level 5, where you don't need people involved anymore. So that's what I'm going to show that we're going to do here. But I think in most cases, most localization companies or departments are not using the tools that are already available on the market. So what my intent is to show you is some of the tools and technologies that are available right now that we can already apply to our production process to significantly increase reach. Okay, so I'm going to talk about two forms of automation. And those two forms are the following. So we have deterministic systems, and these are ones with preset parameters. So imagine a thermostat. A deterministic thermostat is like one on the left, where I take my hand and I set it to a temperature, and it's just set on that temperature, and it will stay there. Okay, now it has a degree of automation because it will regulate the temperature, it'll turn the air conditioner or the heating system on and off, but it's a system that's static. It just has one fixed setting. And we have these deterministic systems in localization. Connectors, file filters, QA scripts are all examples of deterministic automation systems. You set them up, you configure them manually, and then they provide a degree of automation, but they're not very intelligent. On the right-hand side, we have an example of a stochastic system. Stochastic systems are ones in which we learn the parameters from data. So an example of that is like a Nest. I have one actually on the wall just behind here. And a Nest will, thermostat will, has a motion sensor and a couple of other different sensors, and it will determine when I'm in the house and when I'm not, and it will adjust the temperature accordingly. My suspicion is, although I don't know, that there's a very simple machine learning system inside the Nest to help it determine what's the optimal temperature based on the data that it's getting. So this is sort of the difference. The Honeywell thermostat on the left, we program. The Nest thermostat on the right programs itself based on sensors. And we have examples of these in localization as well. Machine translation systems or stochastic systems, as are some of the other tools I'll talk about, like tag placement systems. Okay, but it's crucial that both of these are automation. And so going back to the factory example, automation is a conveyor belt. That's a deterministic system. You put something on it and it goes forward. Those robots that you saw assembling Teslas, those are stochastic systems that you kind of learn from data. Okay, so when we talk about machine learning and AI systems, they're all trained to do a task. And so when I show these different tools, you'll notice that I'm defining different tasks in the production process and matching an AI system with it. And a task is a well-defined goal that a system should accomplish. Some examples of some AI tasks are we want to label each object in an image. You see this in photo applications or when you use Facebook and it picks out the different faces in a picture. Navigate to Arizona, that's an AI task, find the best route to Arizona. Or translate an English sentence to French, that's an AI task that a machine translation system would do. So we define these tasks, and then when we have a task, if we want to make progress on that task, we devise an automatic evaluation measure, and we optimize these systems toward objective functions. So this sounds pretty similar to a production process, and actually this is sort of the way I think about these AI systems as well, which is the task that we're setting up as the production process, the evaluation measure, in our case of localization, would be like the QA scoring system, and our objective function is what we're trying to minimize, which is the total cost per word. Okay, so actually you can think about these AI tools as little production systems that they're set up to optimize a specific task. Okay, so this is what we're going to do. We're going to use AI and automation for optimizing total cost per word, and by optimizing total cost per word, we can maximize our reach. Okay, so let's go through the three components of our budget, the first of which is the internal team. We have 3 people on this team. We have a head of localization, we have a project manager, and we have a localization engineer. Now in the breakfast company right now, I've got in column 2 what each of these roles does. And let's look first at the head of localization. So the head of localization manages the budget. They're the quality owner. They're the ultimate responsibility for translation quality is with the head of localization. And they also function as an internal consultant to their customers to help them do localization. The opportunities for automation here are actually pretty slim. This is a pretty high level knowledge task. We don't really have AI systems that can do that. I think one of the things that a head of localization can do that's high leverage is advocate internally for systems that are localization friendly. So if you're in a company with engineers and your engineers say, oh, we want to build our own CMS to host our website, you should advocate vociferously against that because they're more than likely not going to get localization right. And then you're going to have a very difficult time localizing their website. I'm sure that some of you are in that position on this call. So that's probably one of the higher leverage things that you can do. For project managers spend quite a bit of time on quoting and jobs and delivery. This is where connectors can be really valuable to automate that process. And I'm going to just suggest here you can probably save 25% by adding connectors in instead of doing manual file handling, job submission, and delivery. And then our localization engineer is managing our internal systems, managing our linguistic assets like our translation memory and our term base. And this localization engineer is actually going to train and evaluate MT systems as well. So there's some interesting opportunities for automation here. One that a lot of people do is QA scripts. These are great automation. So instead of, when we do that LQA step, instead of reading every sentence, we can use scripts to go over them to look for errors. This is a really high leverage piece of automation that we can employ if we're not doing that. And I also want to say that actually we don't need to train and evaluate MT systems anymore. The last few years, there have been self-training MT systems on the market that will just train themselves as they're used. And so sort of this notion of the breakfast company right now is, again, pretty progressive. So they're retraining their MT systems every quarter. And so this every quarter when the localization engineer goes to retrain all of the MT systems, we actually don't need to do that anymore. We have MT systems that learn online and they can train themselves. And that sort of job function goes away. So I'm giving a conservative estimate here that 25% of the work that the current localization engineer in our localization department is doing can be automated. And it's likely, depending on your use case and where you are with automation, that this could be considerably greater. So I'm just going to put 25% for both of these two functions. Okay, so that's our internal team. Now let's look at software. So again, we have three pieces of software in our stack. We have a TMS that we bought, we have a terminology management system, and we have some custom MT systems. So the TMS it is our system of record. It has our translation memory in it, which is great. We definitely need that. It lets us do job submission to our LSP. It lets us file reports on what's going on, and it has our file filters. So there are lots of interesting things happening in TMSs right now. Connectors are, sort of the deterministic thing that have been around for a while and are really useful. And if you're not using connectors, you should be. But there are some other interesting things that are coming out. Automatic vendor assignment, so building systems that will assign a job automatically without the intervention of a project manager to either a translator or to a language service provider. This is a pretty well-posed AI task. You can take historical data for who did well on a various job, and you can assign that to them again. There's some interesting research on fuzzy match repair. So taking a translation memory fuzzy match and changing it in various ways so it applies to a sentence. There are applications of document and text classification. So taking one of these products that comes in and determining what type of product it is, and you can use that in vendor assignment. And then MT quality estimation. So if you're using MT, there are systems that will give you some estimate of how good the MT is relative to some measure of translation quality. Now I'm going to put 0% here for breakfast company, somewhat controversially, and I'll say why in a second. And I'll put terminology management in the same category. So term approval and storage is what it does. And there's some really interesting work, actually going back for a number of years, but the technology doesn't work very well yet on what's called a lexicon induction. So this is machine learning systems that are able to extract terms of interest from text. People have been working on these systems for about 15 years. They don't work terribly well, but they can be used as a good starting point. But again, I'm going to put 0% here as the gain that we get. And then finally, custom MT. So if we have sort of a system that we're training all the time, and we're using it for manual system training, and we use it for MT pre-translation before we send to a vendor, we can replace this with self-training machine translation. And so I'm going to say that the sort of custom trained, batch trained MT system, we can eliminate that cost and just have a system that trains itself. So why did I say that for us at the breakfast company, we don't get much benefit from this automation going to TMSs? Well, the reason is because if you're a TMS vendor, you're adding these features to compete with other TMS vendors. And what you want to do is keep the same price or raise the price. So you're not going to get much. You're not going to get much of a decrease in price from these new features, and thus you're not going to get much leverage over your total cost per word. So it's sort of like thinking about, I don't know, take your favorite car, like a Honda Accord or something. If you look at a Honda Accord from 20 years ago, you know, it costs $20,000 or something, and it has a radio and a CD player and cloth seats. If you look at a Honda Accord in 2020, it's got leather seats and an infotainment system and a sunroof and all this sort of, it's like festooned with all this gear, right? But it still costs $20,000. It's not like all this gear that's being added is decreasing the cost of the car because Honda wants to sell you the car for as much as they can. Okay, so we don't get much leverage here in our total cost per word by these very interesting AI features that are coming into TMSs. Okay, now here's where the action is. Remember that in translation is our limiting step. And in fact, this is where most of the tools that we can apply are. So let's say that we have a TEP process. In the translation phase is the first pass. Then we have an edit phase where a viewer or a senior linguist comes in to check adherence to our quality spec and check consistency. And then we have a proofing step where we look at formatting and target fluency, where proofing is usually done by somebody who's fluent in the target language. So we've got all kinds of interesting opportunities for automation here. In the translation phase, here we can apply augmented translations. This is a term popularized by Common Sense Advisory a few years ago. And there are different ways that you can implement augmented translation. One is post-editing that everybody knows. The other is interactive translation, which I happen to have an affinity for. This is what I worked on in grad school. You can choose either one of these, but it's using the machine translation system to automate the first pass of the translation. And then there's some really exciting work too on automating the other translation phases. So some recent work that I'm really excited about is on grammatical error correction systems. So these are systems that can take the output of the first pass of translation and try to propose edits and changes to the translation in much the same way that a reviewer would. We have monolingual grammatical error correction systems right now that are machine learning systems. If you use Google Docs or you use Gmail, you see this all the time. This sort of blue line that appears when you're writing, that's actually coming out of a neural grammatical error correction system. It's monolingual, so it only works on the language that you're typing in. And then there's some exciting recent work on bilingual grammatical error correction systems as well. So right now, I think we're very close to having systems, AI systems, that are going to provide some leverage in the edit step as well. And then there's some very interesting work on tag placement as well. So these tags that we have to manage in localization, typically translators have to place those manually. There's some work that our company has done and others have done as well on automatically placing these tags for translators, and this has gotten a lot more accurate recently. We have a paper out about it this year. Some other people have implemented it in their systems. And so I think, and I increasingly think, that the editing and the proofing phase, the same sorts of tools, these are sort of collapsing because these grammatical error correction systems can do target fluency as well. So I think, and this is certainly what we do in our company, we kind of collapse the editing and the proofing phase into one phase and try to automate that. So we look on the right-hand side, we have pretty significant gains here from the current state of tools that we can implement. And it's really important to note that if you're going to implement augmented translation, it usually requires some kind of different business model to align incentives with the best translators. And one example of that is hourly pricing, which you can implement, but it's possible to do this right now. Okay, so I want to talk quickly, a brief aside about quality, and then we'll go to tallying our gains from AI. So we can set up this whole production process, we can automate in various places, and we can still get killed on our total cost per word. And the thing that kills us is reactive rework. So this is when we deliver translation to one of our customers, and they send it back and they say, I don't like this. So this is exactly what any restaurant and certainly our breakfast company deals with, which is, it's like when we deliver our hot breakfast and the customer says, I don't want this, and they send it back. And they just say they don't like it. So, there could be a variety of reasons for this. Remember the example, the customer walks in and says, I want a T-bone steak and I want it in 3 minutes. And then we present the customer with our nice eggs breakfast and they say, I don't want this, and they send it back. Okay, so that turns out to be really expensive for us and causes a lot of overhead. And oftentimes we find that this is due to expectation setting internally. So this quality definition step where you go to your internal customers, help them define quality and set their expectations for what localization can do, can actually save you a lot of pain with reactive rework. It's going to kill your production process. And there's a hidden bonus here, which I think isn't pointed out often enough, which is that if you set up this quality definition correctly, this will shape the way that translation is done. And this data that's being created in your localization process that's going into your translation memory is also the training data for all of your AI-based language tools. So your MT system, these grammatical error correction systems, the language models that we can use, they're all trained on TM data. And if you set up the quality definition correctly, you're actually going to be generating better data in your production process, which is then going to help you further optimize translation. It's a really, really important point in 2020, is that you've got to be thinking about the data that you're generating so that you can train systems that are better and going to make your production process more efficient. Okay, so if we tally up our savings from before, they sum to $194,000. If we go back in and we see what we've done to our total cost per word, we've actually cut it by 2/3. And we've done that by reducing our translation cost and cutting some of our people and software costs. This boosts our capacity from 1.2 million words to 3.1 million words, and thus it increases our reach from 60% to 157%. So now we can translate all of those 2 million words for the same budget. We're maintaining quality because we have a good quality control process in place. And we have extra capacity that we can go to the breakfast company and we can provide a solution. We can say, look, you can localize more products. We can do more marketing. We can have a bigger website. We can have better training materials for our employees. We could go to, we're ready to go to market in more languages. We can add languages and support the business going to market in more languages, or both. So we've now put a process in place that is going to enable the business to do different things, and we've given the business decision makers tools that they can use to drive business results. Or we could come in under budget and be heroes. Now that frequently doesn't happen in the enterprise, but we've got a path to that here. If we only translated our 2 million words, we have capacity for 3.1 million words, then we can come in significantly under budget, and that's valuable to the business too. There's no business leader around that wouldn't like to have one of their departments come in under budget. So we've got some really interesting tools at our disposal that we can use strategically in our business to drive business results. So here's what we've done. We've thought about localization as a production process. We've thought about using AI and automation to optimize that production. By doing so, we've maximized reach, and now we have capacity to support the business with its business objectives. And then that goes to drive real business results, either by reducing budget or reducing cost, increasing capacity and giving the business more flexibility to go to market in more languages or provide a better experience in any particular language. But we've given our business strategic tools that it can use internationally. Okay, so last slide, and then we'll get on to some questions. So here's my challenge to you, and here's some homework. These are some questions that you can ask. You can go look at the localization that you're doing, and you can think about what is my objective, and think critically about that. Saying that your objective is quality is not critical enough. You need to think harder about defining the objective for your production process, and then think critically about the key inputs to that process. You can't set up a process until you know exactly what the key inputs are, which are the products that I'm localizing, the standards, the quality standards that I have for each one of these products, and how many words are in each one of the products that I'm localizing. You should think carefully about your key production metric, It's not just what you're paying your outsourced LSP, it's all the other costs that you have in localization as well. And compute your total cost per word, and then think critically about how you can optimize that. You can ask some questions and work collaboratively with your vendor. And went into some of the AI tools that are available for automating translation, you should be working with your vendor on implementing some of those tools. And what is the vendor doing to return these savings from implementing these technologies that are trained on your training data, the training data that you have in your TM, that you are collecting and curating as part of your quality process? What's being done to return some of the savings from applying these AI tools to you? What's my quality specification, and how is this helping me generate better data for me to train these AI systems, these stochastic systems that I'm using to optimize production? How much reactive rework am I doing? If you're doing a lot of reactive rework, you're delivering things to internal customers and they're sending them back saying, you know, this isn't good enough, or this isn't our brand and voice and tone and whatever. Instead of saying there's something wrong with production, I'd encourage you to go back to the beginning of the production process and think about your quality specification and the expectation setting that you're doing with your internal customers. And if you can cut down on that rework, then you can optimize your total cost per word. And then finally, how much revenue as a business are we missing out on due to low reach? When the breakfast company was trying to go to market in these 5 languages, and we were only able to cover 60% of the content, a critical question is, like, what are we losing? What are we sacrificing by the fact that we can't reproduce the whole product experience in each one of the markets that we're trying to sell in? And I think that's a critical question to ask of the business and to ask of yourself as well. Okay, so I'll leave that on the screen for a second. And I think we'll put these slides up on our blog afterwards. I know there's a recording of this as well. There's a lot of material in here, but we'll post these so you can have a look at this after the talk. And then with that, I'll say thank you again. I hope you're safe and healthy out there wherever you are. I'd be happy to take some questions. And I'd also really appreciate, I'm really eager to hear your feedback on some of these ideas. And if you go off and ask some of these questions and you have experiences with them, I'd love to hear them. Either good or bad feedback. Both are interesting for learning and improving production. So thanks very much for the time this morning.
Thank you, Spence. We do have a couple of questions here from the audience. First, let me start with something that you're getting mild pushback on, and that is the notion that TMS term innovation doesn't benefit a company. This is a client company, and they're saying that it has benefited them tremendously by vendor costs going down, process time shortened. So I'm wondering if you could comment on that.
Yeah, I did. So I made a simplifying assumption that in the that we weren't gonna talk about turnaround time. So I think a lot of these innovations here, vendor assignment, the quality estimation, fuzzy match repair, a lot of these are gonna accrue to speed. And I think that's a valuable thing to think about, but I made a simplifying assumption here that we're not gonna do that. I also think that some of these innovations here, depending on how you have your project management set up, whether you're doing you've outsourced project management or you have an internal project manager, a lot of these tools here are going to optimize what the project manager does. So I set this gain here conservatively at 25%, and this may be a case in which you would increase this value and you would say that that's because of these tools. But you're not getting a cost reduction. It's not as if your TMS vendor is adding these features, and instead of charging you 100K per year, they're not going to charge you 20K per year. Okay, so you're not really optimizing your total cost per word in the software bucket. You could be optimizing it here by reducing your project manager costs.
Cool. We got another question here that I would probably have to read in whole, but it's about stochastic systems, like the Nest example that you gave. They're cool next-gen products, but the questioner here says they raise other issues, like for IoT devices, they leave those open to cybersecurity risk, and those can be super costly to resolve. And that wasn't an issue with deterministic systems. So the question is, as you're introducing these stochastic solutions, are you seeing any knock-on side effects like that? And if so, is there any drag on reach?
Yeah, so I use this word stochastic. This means probabilistic, and I just use this refers to all machine learning systems that you train on data. And I think the question that's being asked is these sort of security and privacy questions, and these are not the consequence of the machine learning system, of the sensors that are outfitting these products. So the most the best example of this is like these smart speakers that people have in their houses now that are listening all the time. And it's not the machine learning system inside the smart speaker that's the problem. It's the microphone that's listening to your house all the time that's the problem, and the data that's being collected from your house. So a machine translation system is an example of a stochastic system. You can train it completely offline on data. It doesn't have any sensors attached to it. There's no real issue there. It's really the sensors that are kind of what are worrying and worth thinking about.
Okay. Alrighty, any thoughts on how we can use AI related to language materials such as translation memories and also in the process of cleanups? Any thoughts there?
Yeah, sure. So there is some work on fuzzy match repair. So this is doing something like you have an 80% match, and can you use a machine learning system to change it in various ways to turn it into a 100% match? And that is really useful, and that is a source of leverage. If you can turn things into 100% matches, then that optimizes your total cost per word. Remember, in this example, I said I wasn't going to include fuzzy match calculations or TM leverage calculations just to make the math simpler. But I think that's really valuable. I tend to think about the translation memory in 2020, not so much for recycling, which is an important idea, but I think about it as the training data for all of these language systems that we want to train here, which indeed they're all trained on the translation memory basically. So I think the more helpful way to, the important thing to think about with TMs these days is the guidelines that you're using that are creating that training data. And you can think about translation as annotation, really. And I'm sure there are some people working at LSPs on the call who have data labeling businesses, which, data labeling for self-driving cars, for instance, is taking images, and you have a person say, this is a car, this is a tree, this is the street, that's a stop sign, and they draw these boxes. Translation is sort of that. We're taking English sentences and we're labeling them with French sentences. And any data labeling business has an annotation guideline. It would be crazy to do data labeling without an annotation guideline. So I think the really important thing to think about is the quality specification or the text specification that is being used to generate this training data that ends up in our translation memory.
Mm-hmm. Thank you. We got one more question, a little similar to one that was just asked, and that is in your production analysis slide on Team Internal, you have a column for potential savings, and you mentioned 2 lines of 25% potential savings. What exactly are you actually saving here? I mean, whose time are you saving?
Yeah, so I said I'm saving this here as the amount of time for each one of these roles. So for the project manager, I'm suggesting that you can use connectors if they're doing a lot of file manipulation. Then you can cut down on that. For the localization or MT engineer, you can cut down on training MT systems. Now you can say how do you save 25% of a person? You can't just cut their arm off or something like that. Well, actually, as this sort of scales, if you have 4 project managers and you're saving 25% of each one of those, by the time you get to 4, you've saved an entire person. So that's how this kind of comes in. When you're less than saving an entire person, well, internally in a business, what you can do is you can have people with dual roles, or you can outsource and have a contractor who's working part-time. Those are both ways that you can realize those savings.
Mm-hmm. Thank you. And I think here comes the last question, because that's all we have time for, and it's a good one. If quality expectations change or shift, how much does it actually affect existing or old trained data? Do you have to retrain it with the new information?
That is a great question. So this very much is a thing. Language is productive. It changes over time. 3 weeks ago or 4 weeks ago, none of us were using phrases like flattening the curve or social distancing, and now these words are used all the time, right?
Right.
So words and phrases change all the time, and this is called domain shift in the data. This is what people who work on domain adaptation, this is one of the core ideas that they work on, is dealing with domain shift. And most systems domain adaptation, they will have a recency bias. So they will tend to bias more towards things that they've seen recently. And so they'll sort of pick up domain shift. And so in general, I think my recommendation is that all data is valuable, don't throw it away. And if you can order the data somehow temporally, which you can do with a translation memory, it has timestamps on it, and the system trains itself that way, then this should, if the domain adaptation works correctly, it should kind of take care of itself.
Thank you. Thank you so much, Spence, for taking the time today and laying out how localization can become more scalable. And another big thank you to all of our audience members for joining us today and for posting your questions. We would really appreciate it if you could take just a minute to give us your feedback on today's session using the post-event survey. I will share the results with Spence, so he will get it for sure. But we really would like to get your perspectives to help us continue to refine our webinar program. And with that, I wish you a good day or good night, depending on where you are. I hope you are all safe, and I hope to see you at another Gala webinar soon. Thank you and goodbye.